Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. This is Ziad Abu Zaid. And this is a math problem here that I found interesting. Someone shared it on Twitter. And when I was looking at it, right away, there was like kind of two things that came to my head. One was there's probably an easy shortcut to fix this. Another one is something seems off about what I'm looking at. So the first off, what happened was you see a bunch of threes, fours, and fives. And right away, when you see a 3, 4, and 5 in a triangle or with angles, what comes to mind is a 3, 4, 5 triangle. So if you, as long as you know two of the sides, you can figure out the third one. Because for a right triangle, 3, 4, 5, using Pythagorean theorem. So let's see. If I draw a line here, this is 5. And if I bring this vertical line over here, 3. So then this becomes 4. 5 plus 4, 9. So less than 10 seconds, boom, problem solved. Now, for the second thing that came to my head, something seemed a little bit off. I guess eventually what I figured out was this 3 and this 3, one of them can't be 3 because you have this 3 which looks really long and this 3 which looks not as long. So the scale of the lines, so each individual line wasn't drawn to scale. And on a math problem, they'll usually give you that hint. They'll say, drawing not to scale to kind of let you know that you can't just do this kind of mental math shortcut in your head. And, in this case, so this is almost like a trick problem. Now, trick problems, again, they usually rely on you trying to use a shortcut or trying to use something that you would do under pressure into a predictable trap. And the predictable trap in this case was trying to take advantage of, again, it's a good good mindset. Yeah, okay, I can recognize 3, 4, 5 triangles. But when the problem isn't drawn to scale, that kind of throws everything out the window. So now we have to think a little more formally about how this kind of problem is tackled. Now, right away, the next step is all of the lengths of these lines, and this looks like a geometry / trig problem. So let's draw a horizontal projection completing these, 3 mini triangles. So we'll call that line 1. I'll draw a vertical line here, then a horizontal line here to this corner. Let's call this line 2. And then continue the horizontal line here and a vertical line here, line 3. So everything, regardless of whether things are drawn to scale or not, I know for a fact that line 1, line 2, line 3 will add up because the endpoints all line up to are the same northing, if that makes sense. So everything lines up on this left side, everything lines up on this right side. So they have to be the same length. Now, okay, so there's some progress here. Now, for each of these lines, all we know is that they're in a right triangle. Let's just redraw that right. They're in the right triangle. And that's about it so far. So let's do a little bit of trig and figure something out. I know in order to get the length of line 1, I'm going to need to know, say, this angle here. Let's call it angle 1. So that angle 1, if I use the sine of it, is it the sine of it? Yeah, I could think of it as the sine of it. Let's see. Does it have to be like that in particular? Let me think. What is going on here? Does it have to be the sine of the angle? Yeah. Let's call it angle 1. Okay, so I know that for this, okay, yes. So I know that for this, we have, if I know this angle, I'll know the length of the other two sides. So I'll know what the length of this is. I know what the length of this is. I also know that sine of the angle will equal this line 1. And then we have number 2, for this line 2. What else is there we can do for that? Let's see. Now I know, okay, this angle is angle 1. This angle here is 90 minus angle 1. Because these two have to eat up to 90, and then the right triangle gives us the last 90 for a 180 degrees. And given that, this is now angle 1, which makes this 90 minus angle 1, which makes this angle 1, which makes this 90 minus angle 1, which makes this angle 1. Okay, nice, nice, nice. Now there's no way for us to know what these angle 1s are, unfortunately. So just by trying to figure out the horizontal line. But we do know what the vertical lines will all add up to, which is 3. So if I go up this, 3 cosine angle 1, I go down 4 sine angle 1, and I go back up 5 cosine angle 1, has to add up to 3 because the endpoints here are the same. All right, so let's see if we write that down formally. 3 cosine angle minus 4 sine angle plus 5 cosine angle equals 3. Okay, so let's see what happens. If I do that, so here, what I'm going to do, I'm just going to combine the 5 and the 3 to get 8. And then now I have a cosine and a sine and a number. Now, so it's hard. It's hard to really. You can't really combine a cosine and sine into just one number. It's going to be I'm going to have both cosine and sine, so it's a little bit annoying here. So I'll at least separate them. Move the 4 cosine angle on the right side and move the 3 over to this side. So we get something along the lines of 8 cosine angle minus 3 equals 4 sine angle. Now I can take advantage of some trig identities, the classic cosine squared plus sine squared equals 1. So if I kind of rewrite that sine angle in terms of in the context of this formula here, I'll get something along the lines of the square root of 1 minus cosine squared theta. And now, to get rid of that little square root symbol, we'll just square both sides. And this equation expands again. 64 cosine squared theta minus 48 cosine theta plus 9 equals 16 minus 16 cosine theta. Now again, there is some still hand waving on what's going on between here to here. And that's just some more basic algebra. So I'm just kind of skipping over that. You may have to just trust me for now, but I'll explain why later. So now we have this little angle here. Well, not really angle, it's equation. Now let's throw everything onto the left side. We have 80 cosine squared angle minus 48 cosine angle minus 7 equals 0. And this here allows us, once we have it in this form, we can take advantage of the quadratic formula. So you'll notice, so the negative b, my b rather is negative 48, a is 80, c is minus 7. So if I do that, I have cosine angle has to be negative b, which comes up to 48, plus or minus the square root of b squared minus 4ac. So the b squared, 48 squared, negative 48 squared, same thing, minus 4, the a, the 80, the c, negative 7, over 2a, 2 times 80. So now, if I were to just solve that out, I get cosine angle equals 0.7288. And so once we have that, you can kind of just take the inverse, the arc sine, the arc cosine of both sides, and you'll get it to an angle equals something. So if you were to put in a calculator, you probably I think you'd get something like 43.8 something and whatnot. Because I've already solved this already. So let's see what we got. If I were to go to here, so arc cosine of 0.7288. Is it 7288? Let me see. 7288. Okay. Oh, you know what? It's probably it's probably somewhere close to 7288, but not exactly. Another way we can do it. Let's just draw it out. We have 80x squared. I believe it was minus 48x minus 7. Okay, 7213. So we're a little bit off. 7213. So this is another way you can kind of solve it. You just graphically draw it out, and you find out where it crosses the 0 axis, because that's where it equals 0. Cosine can either be in negative. The angle will either be, I guess, negative or this. So let's look at the positive case. So if we have 0.7213, we're in degrees. Arc cosine of 0.7213. Yep, 7213. So we get an angle about 43.838 and whatnot degrees. So now, going back to this thing here. All right, so if I were to go for the length, then I would just kind of flip everything. It would be sine of 3 times sine of angle 1, 4 times cosine of angle 1, 5 times sine of angle 1. So let's see what that looks like. So if it's 3 times sine, let's make this equal to A plus 4 times cosine A plus 5 times sine A. So 8.426. So you get something that's a little off. So it's in terms of percentages. So let's call this Q. If we were to say, all right, so if our initial assumption of 9 was about, a little versus about 7% off, 7% off from the actual answer. And when it comes to math, that's for engineering, there's a you have a margin of error that you're allowed to use, but for a math problem like this, they're probably not going to give you they're going to give the answers really close to each other. So if you did it the other way, you would have definitely gotten it wrong. So let's go back. So this is what we end up with. Now, another way you can just look at this is once you have this trig thing going on here, you can just kind of set up the second equation that we use just to determine the overall length, and we can try it out programmatically. So here's some Python. I'm going to import the math module just because we need it to do some math things. I'll set my angle to 0. I'll have this function where this YOLO variable is basically that our very first equation. So if I by bringing it here, so 8 cosine angle minus 4 sine angle minus 3 equals 0. If we brought only the 3 over, all it's doing here, it's just working out the math and seeing if that if we're like 0.00000 0.4 zeros and 101 away from 0. So we're just kind of figuring out like, if we're really close to 0, then we're pretty much at that angle, and then return if it's a true or false. So right now it's not solved yet, and all we're going to do, we're going to keep on calling this math equation and changing the angle a little bit each time until we're really much near 0. And once we know what the angle is, I'm going to use it in that second equation. So see the math, 3 times sine angle, 4 cosine angle, 5 sine angle. So if we run it, boom. Yep, so we get the same thing. The angle is about 43 and some change, and the length was 8.426. And now a third method is just to draw it out. So I have over here FreeCAD, and I just recreated the problem and had the same constraints. So this is a vertical line, length 3, horizontal line length 3, line length 4, line length 5, and I made this 3 line and 4 line perpendicular to each other, and that 4 line and 5 line perpendicular to each other. So I just recreated it except the lines to scale. And I have a reference dimension of the angle 43.8375, and the length is basically the same as the other 2 methods that we were looking at. Now the kind of like the I guess the, what do you call it, the goal or the theme of this was trying to do stuff in your heads quickly when you're seeing something that appears to be simple, but in reality, it actually takes you, having to sit out and draw it out. Now, if you're just scrolling through Twitter or internet or whatever other website that people do these days, and they come across some issue, I'm pretty sure 9 times out of 10 we usually just try to think it out in our heads and then just put a response. And that is a very dangerous habit to get into, because as much as the human brain is very good at reasoning and logic and whatnot, a lot of things, especially if they're presented to you in a manner that's distorted. So in this case, this was a distorted drawing that had superimposed just these lengths on them. It really requires you just to sit down and take the time. And that's usually what people don't do, is take the time and sit down and work it out. And it doesn't necessarily require you to be a complete expert in the matter. So in this case, I skipped a lot of steps in using geometric proofs to show first that a triangle is 180, and parallel lines with the same bisecting angle produce the same angle on each side, and a lot of stuff. And again, the deriving what is this this trig identity, the cosine squared sine squared equals 1, setting up the quadratic formula. The quadratic formula especially is a very wonderful derivation. I really enjoyed actually deriving it. Because you do it once in middle school and then you forget about it, and then you kind of try to think like down the road, how do we actually get the quadratic formula? Why does it work? It's a nice thing to do one of these days. And then coming down all the way to here, cosine angle equals, in this case it was 7213, and deriving that final angle, or even then understanding this method, why drawing out and setting it to 0 works. And even though it's, this is kind of the simplest way to do it. Just draw it out and measure what you get. In order to draw it out appropriately, you still kind of have to know the angle you're doing with, because at least when you're drawing, you can't just arbitrarily just draw a line and move it. If you say you made a bunch of little links, you actually had some sticks with that you measured out and glued in shape, and then measure along the top. It's still, again, each method, even though they each have varying levels of complexity or prerequisite knowledge to kind of get, they still, again, require time and some sort of tool to help you out. Because even then, even I can get maybe up to this far, just kind of drawing out, which I kind of did here. But then once you have cosine of an angle is 0.7213, I mean, maybe the best I can do is try to draw a circle with the radius 1, and then try to figure out like what angle do I get 0.7213 for my horizontal projection. So there's a lot of stuff that takes time, some sort of effort, and again, having a little bit, just enough insight to say, okay, instead of coming up with what's in my head, at least if I don't already know the math, take the time to learn the math, or I guess in the more broader sense, whatever subject you're trying to get into. Get competent in it. I mean, the barrier for competency to solve this kind of problem isn't that high. It's just, again, you just have to know the method and have enough exposure and doing it, enough times practicing it so you become familiar. If nothing else, you won't be off. You won't be off by more than half an inch. And when it comes to math, engineering, religious verdicts, religious opinions, I'm pretty sure being more than half an inch off can be very detrimental. So that's kind of what I had in mind today. I just like math problems like this. So yeah. Assalamu alaikum wa rahmatullahi wa barakatuh.